So now let us move to the next question, children. That is sixth question. The kinetic energy of a given body is doubled, its momentum will be. So what is given? That kinetic energy of a body is doubled and you are asked to find the momentum. So condition for momentum. What is the formula for momentum? Momentum P can be given as root over 2mk. So given body for the same body as they have told, this implies that mass is constant and of course 2 is constant. So P is proportional to root k. But in the given question, what it was given is kinetic energy of the body is doubled. Suppose if the value of first kinetic energy is k, then next kinetic energy will be double that of that. So 2k. So K1 is K and K2 is found to be 2K. So comparing these two, we have P1 upon P2 is equals to root over K1 upon K2. Sorry. P1 upon P2 is equals to root over K1 upon K2. What is K1? The value of K1 is taken as K and hence K2 can be taken as 2K. Okay, K1 is K and K2 is taken as 2K. Substituting, how much you are getting, children? You get this value as root over 1 upon 2. Root over 1 is 1 and root over 2 is root 2. If P1 by P2 equals to 1 by root 2, what we observed is P1 by P2 is equals to 1 by root 2. Then cross multiplying this here and this here. Then we observe that root 2 P1 is equals to P2. So clearly we found that P2 is equals to, what is that, children? P2 is equals to root 2 times of the initial momentum. So where is the correct option? Momentum becomes root 2 times of that initial momentum. So becomes root 2 times. So fourth option must be true. So direct formula. Moving to the next one, seventh question. When the kinetic energy of a body is increased by 3 times. Now what is changing? Kinetic energy is changed to 3 times. Its momentum is increased by. So formula for momentum is P is equals to root over 2mk. So what is given? Of a body, that means body remains constant. So 2 is constant and the body remains constant. So mass is constant. So clearly P proportional to root K. So what is given means, given condition, kinetic energy of a body increased by 3 times. Let us suppose the initial kinetic energy as K. Then the final kinetic energy will be 3 times of the old one, that is 3K. So comparing the two, we have P1 by P2 is equals to root over K1 by K2. Root K1 by root K2, root over K1 by K2. What is K1? K. And what was K2? 3K under root. K upon 3K under root. After further simplification, K and K gets cancelled. Then you are left with root over 1 upon 3, that is root over 1 by 3. It can also be written as 1 by root 3. Root 1 is 1 and root over 3 is root 3. So very clearly we found that P1 upon P2 is equals to 1 by root 3. Okay, so if P1 upon P2 is 1 by root 3, cross multiplying, what we get is, so root 3 times of P1, root 3 times of P1 is equals to P2. Root 3 times of P1 equals to P2, or clearly the value of P2 is equals to root 3 times of the initial momentum. So becomes root 3 times. Hence the correct option is option 4, that is root 3 times. Seventh option, seventh question, fourth answer. Moving to the eighth one, children. A light and a heavy body, light, lesser mass, heavy body, larger mass, have equal momentum. Now momentum is equal. Which one will have greater kinetic energy? So what is the formula for kinetic energy, children? We know that kinetic energy Ke equals to P square by 2m. Given condition is they both have equal momentum. So P is equal and 2 is constant. So clearly K is inversely proportional to mass. Whenever K is inversely proportional to mass, it indicates that larger the mass, lesser will be kinetic energy, and lesser the mass, larger will be kinetic. Inversely proportional. Less mass, more kinetic energy. More mass, less kinetic energy. So, what is the correct answer? Which one will have greater kinetic energy? So, for greater kinetic energy, this implies mass should be less. So, large kinetic energy or greater kinetic energy. If you want this as greater, then mass should be lighter. So, where is that? Which one will have greater kinetic energy? Lighter mass will have greater kinetic energy. So, option 1 must be true, that is the light body. So, moving ahead with the 9th question, children. Two bodies of masses m and 4m are moving with equal kinetic energy. So, what is given? Two bodies of masses m and 4m. Masses are different, moving with same kinetic energy, ratio of linear momentum. Okay. So, the relation for linear momentum is what is the formula for linear momentum, children? P is equals to root over 2mk. So, you are asked to find the ratio of the linear momentum. Masses are different, moving with equal kinetic energies. So, here kinetic energy is constant and 2 is also constant. So, clearly we have P is proportional to root m. So, in order to compare this, P1 upon P2 can be given as root over M1 upon M2. But what is given condition? So, given condition is that first body mass M1 equals to M, second body mass, two bodies mass M and 4M is given as 4M. So, M1 is M and M2 is 4M. Substituting the same over here. So, how much you are getting? Under root. M1 is M. M2 is 4M. So, simplifying, you get M and M gets cancelled. So, you are left with the under root 1 by 4. So, root over 1 is 1 and root over 4 is 2. So, clearly P1 upon P2 is found to be 1 by 2, or P1 is to P2 is equals to 1 is to 2. So, therefore, the correct option is 1 is to 2. So, here the third option is true. Okay. So, P1 is to P2, the ratio of the linear momentum is found to be 1 is to 2. Moving ahead with the next one, 10th question, children. A particle of mass m has a momentum p and its kinetic energy will be. So, what is given? Momentum is given as p and you are asked to find out the formula for kinetic energy. So, what is the formula for kinetic energy? P square by 2m. So, directly it was given P is equals to mass into velocity. This implies velocity equals to P by m. So, kinetic energy is equals to, you are asked to find out kinetic energy, half mv square, and half times of m times of v can be replaced with P by m whole square. Half mv square, v is replaced with P by m, v square means P by m whole square, which is equals to half m multiplied by P square by 2m. After further simplification, m and m gets cancelled. Hence, you are left with the P square by 2m. So, we concluded that the value of kinetic energy equals to P square by 2m. Therefore, the correct option is option 4, that is P square by 2m.